We'll start at point 1, comma 0 on the unit circle. Unit circle has radius 1, center 0, 0, and the equation of the unit circle is x squared plus y squared equals 1. Now let's start on the unit circle at point 1, comma 0, and we'll measure an arc of length s along this circle. We will say x comma y be the endpoint on this arc. If your arc length is positive, then arc is measured in a counterclockwise direction. If arc length is negative, then arc is measured in a clockwise direction. If arc length is 0, then no arc is measured. That the measure of this angle theta is related to the arc length. We know that arc length equals radius times the angle theta, where theta is measured in radians. Because we're on the unit circle, we can say that radius equals 1. So S, which is measured in linear units such as inches, centimeter, meters, is equal to theta measured in radians. The trigonometric functions of angle theta in radians found by choosing a point xy on the unit circle can be written as functions of arc length s, which is a real number. When we interpret this way, the trigonometric functions are called circular functions. So the definition of circular function is this: for any real number s, sine of s, which is equal to y, cosine of s, which is equal to x, tangent of s, y over x, as long as the denominator is not 0, cotangent of s, x over y, y can be 0, secant of s, 1 over x, denominator cannot be 0, cosecant of s, 1 over y, denominator cannot be 0. Recall one thing. In the earlier section, we said sine theta equals y over r. But now as we say that s, which is measured in linear units as inches, centimeter, or meters, is equal to theta measured in radians. So we can replace this with s, and our radius for the unit circle is 1. And this is how these circular functions were defined.